Hello class, today we're going to be reviewing how we multiply fractions. So first off, we want to remember that when we multiply two factors just meaning numbers that are multiplied together, and if we have a multiplication statement like a times b, that's going to mean a groups of b size, b in each group. So if we have a multiplication statement like the whole number 2 multiplied by the fraction 3/5, we can interpret this as two groups for 2. Multiply sign always means of, and then we are going to have our fraction, which is 3/5 in each group. So how could we solve this out? Well, we could start by thinking about having 3/5. So I've got 1, 2, 3 parts shaded in out of 5 total parts in this circle. And then I need two groups of that. So here's my first group, and here's my second group. And if I think about, well, how many parts do I have in total actually shaded in? I've got 3 there, another 4, 5, 6 in the second group. And I could say altogether then that I have 6/5. 1, 2, 3, 4, 5, 6 sections shaded in, and each section is a size of 1/5. So I could say that my answer here is 6/5. Now, if I think about, well, how do I get that from the math? I'm going to notice that on top, my 2 multiplied by my 3 is what's going to give me my 6. Don't know what's happening there. And on the bottom, I'm not changing that number. There's still fifths. I haven't changed the size of each part. And so it seems like if I'm going to multiply a whole number by a fraction, I can multiply the whole number by the top and leave the bottom alone. I'm not changing the size of the parts. And that will give me my answer, 6/5. Now, of course, just quickly while we're here, let's notice that we could also write that 6/5 as a mixed number. We've got one whole entirely filled in, and an extra 1 out of 6 parts. So we could say that this is 1 1/6 as a mixed number as well. And that's going to be the answer, or the product of our multiplication. Product meaning the answer to a multiplication statement. So far that's all well and good. It looks like if we have a whole number multiplied by a fraction, just multiply the whole number by the top, the numerator, and leave the bottom alone. We can also confirm that by thinking about our grade 7 knowledge of being able to add fractions. We've got 3/5 here, plus another 3/5 here. And we can go ahead and say, well, when we add fractions with the same denominator, or a common denominator, we can add the tops and leave the bottom alone. And of course, that also gives us our product of 6/5, which is what we thought it should be. So that seems like it's a pretty good representation. Now we're going to extend this idea using a couple of tricks. Before we get into the actual process itself, let's just first off remind ourselves that fractions are numbers in and of themselves and can be made into equivalent forms. So one of our tricks is that we can simplify fractions before we start multiplying. You might notice that this problem here is actually the same size and shapes as the previous problem of 2 times 3/5. We've just written the 3/5 in a different way as 6/10. So if I wanted to simplify this problem before multiplying, I could go ahead and combine every group of 2 sections here. And that would give me an equivalent fraction. What am I doing there? Well, I'm simplifying this fraction by dividing it by 2. So I still got my whole number 2 up front. 6 divided by 2 is 3, and 10 divided by 2 is 5. Obviously, this is the same problem as before. We just made it look a little bit different, a little bit easier. In this problem, you might not necessarily have needed to do that, but in larger number problems, this trick can help keep our numbers smaller. So we can definitely simplify fractions into equivalent forms. Before we multiply, we're going to end up with the same result. The second trick is more relevant to our procedure, which is that a whole number can be rewritten as a fraction. So we know the statement to be true, 2 times 3/5 equals 6/5. And I know that 2 wholes is 2 out of 1. 2 parts, where every part is 1 whole. And if I now multiply that and I think about, well, how do I end up with the answer 6 out of 5? Let's in fact move that over a little bit. Well, I already know I'm going to multiply the top numbers, 2 times 3. And my question is, well, what do I do with 1 and 5 to end up with 5? Do I add them? Do I subtract them? What do I do? Well, obviously I'm just going to multiply those as well. And so that leads us to our overall procedure for multiplying fractions. There's kind of a step 0 to make your life a little bit easier, which is to rewrite the problem in any ways that we can. We are going to write whole numbers as fractions over 1. We are going to simplify fractions wherever possible before multiplying. Again, this trick just keeps our numbers smaller, and it makes it easier to reduce in step 3. After we've done those tricks, we're going to multiply the top number by the top number, we'll multiply the bottom number by the bottom number, and we'll reduce or simplify our answer. So let's take a look at a couple examples of that. First one here we have is 2/3 times 3 over 4. If I look at these fractions, I can't reduce them in any way, and neither of them are whole numbers. So I'm going to go ahead and just go right into step 1, multiply the top by top. So I'm going to do 2 times 3. Those are my top numbers. Step 2 is multiply bottom by bottom. And obviously I've got a 3 and a 4 on the bottom. And I'm going to do those multiplications. 2 times 3 is 6, and 3 times 4 on the bottom there is 12. And then our last step in any fractions problem is always to simplify or reduce. And so I'm going to look at my 6 out of 12, and I'm going to say, okay, both of those numbers are able to be divided by 6. 6 divided by 6 is 1, and 12 divided by 6 is 2. And so I could say my simplified answer here is 1/2, and that is my product. Now, how can I sketch out this problem? It's a little bit harder because how do I have 2/3 groups? Can't usually have less than one group. So how I'm going to interpret this problem instead is I'm going to say that I need to take 2/3 of a drawing of 3/4. So let's go ahead and start out by drawing 3/4. I'm going to use a rectangular hole for this one. And 3/4 means that my hole is split into 4 equal sections. And then I actually have 3 of those. So 1 section, 2 sections, 3 sections out of 4 are filled in. And that's a drawing of 3/4 so far. I don't want all of that 3/4, I only want 2/3 of that 3/4. And what that means is split that drawing into 3 parts. So I got 1, 2, 3 equal parts. And I need to take only 2 of those parts. Only 2 of them are important to me. So here's 2 of those 3 rows that are important. And so what do I actually have? Remember, the only things I have are things that are shaded. And in this case, I only want things that are shaded twice because they're in both kind of descriptions. So those are these cells here. If I count them up, I have 1, 2, 3, 4, 5, 6 cells in total. So that's going to be my numerator. And how many cells are in this one whole rectangle? Well, I've got 6 there, 7, 8, 9, 10, 11, 12 in total. And hey, look, presto, I've got that same answer as before, 6 out of 12. And of course, I could simplify this and say, well, it's actually 1/2 of the diagram. So that's how I would go ahead and sketch one of these fraction multiplied by fraction problems. I'm going to use one of the fractions to represent the rows. In this case, I said 2 rows out of 3 for my first fraction, 2/3. And I'll use the other fraction as my columns, 3 columns out of 4. And my answer is going to be the shaded in section out of the total number of boxes in my drawing. Let's look at one more example. Let's take a look at this one. Now, if I tried to draw this out, or if I was asked to draw this out, it would be a bit of a pain as it is. You know, I don't want to draw 24 columns, and how do I have 24 out of 18 in general? But what I can do is remember my rewriting trick, and I'm going to be able to simplify. If I look at 24 and 18, You could simplify this in more steps than this, but both of those are able to be divided by 6. So if I simplify that fraction, I'd have 24 divided by 6 is 4 on top, and 18 divided by 6 is 3 on the bottom. And I'm going to multiply that by my other fraction, which was 3 out of 4. Now I can go ahead and multiply top by top. 4 times 3 is 12. And I'm going to do step 2, multiply bottom by bottom. 3 times 4 is 12. And I'm going to reduce. Another way of saying reduce is to simplify. 12 divided by 12 is 1. So you can see there how my simplification trick at the start makes that a lot easier, keeps my numbers a lot smaller. I could, of course, do 24 times 3 and 18 times 4, but since those are outside of my times table, that's a little bit harder. So simplifying and rewriting that problem in a simpler way is obviously a little bit easier to engage in. So those are some of your basic types of fraction problems. The only other trick that we have is sometimes we'll have mixed numbers in our fraction problems. So let's say like we had 3 and 1/2 multiplied by something. Let's do 3/5. To be able to multiply these out, we need this to not be a mixed number. So a final kind of trick is that we need to convert mixed numbers to improper fractions to be able to multiply them. So how do we do that? Let's again remember from grade 7. If I have 3 holes and each part has 2 sections in them, I'm going to do 3 times 2 gives me 6 sections in those 3 holes, plus my extra 1 section from my 1/2, and each section or each hole is split into 2 parts. So I'm going to say that mixed number there is actually the improper fraction 7/2. Now I can just do my normal process, 7/2 times the other number was 3/6. I'm going to do top times top, 7 times 3, bottom times bottom, 2 times 5, and that gives me 21 over 10. These do not share any common factors, so I can't simplify that any further. Improper fraction would be 21 over 10, or I could say as a mixed number, 10 goes into 21 2 times with 1 left over. So that would be my mixed number answer. So hope that helps you with some of our ideas of multiplying fractions.